Okay, what we see in front of us right now is a even G emulation, and what we have is we have three 9K devices that are connected. Now, what I want to do is I want to be able to make an attempt to illustrate what the OSI model configuration looks like. Now, what I've done is I've gone to each of these devices and I've configured IP addresses. So if I come in and I type show IP interface brief, and we look at the outcome here, we can see that this interface is 10.1.12.1. That's the interface right here, E11 on 9K1. Now, what I want to do is I want to test reachability. So I'm going to say ping 10.1.12.2. That's the IP address on the other side of this link between 9K1 and 9K2. I'm going to go ahead and see if I have successful pings, and that tells me everything's good to go. Now, what I'm going to do is I'm going to go to 9K2. I'm going to log in. And what I'm going to do is I'm actually going to activate some features. I'm going to come in here and I'm going to say configure, and I'm going to say I want to turn on the feature of the NX API. And that is going to allow me to be able to connect to this device remotely in such a fashion that I'm going to be able to initiate a session. So let me turn my mail notification off here. That way we're not constantly being harassed by incoming messages. Now, this feature should allow me to be able to connect to this device. So what I'm going to do is I'm going to go back to 9K1, and what I'm going to do is I'm going to use telnet to 10.1.12.2. But what I want to do is I'm going to say I want this device to connect using port 80, which what that translates to is I'm going to do a TCP connection to the HTTP well-known port. And if all goes well, it should allow me to connect. Now, this is not an actual browser, so I'm not able to do too much, but you can see here that I am indeed connected. And if I hit Control C, I'm going to be able to break that connection. Now, what I want to do is I want to be able to verify these connections. So I want to look at what happens across this link, and the easiest and best way to do this is going to be using some type of sniffer. Now what I'm going to use an application called Wireshark. You will see this over and over and over in this and other video series, because I think it's absolutely critical that we have a firm understanding of what the information that we're sending between devices actually looks like. So what I'm going to do is I'm going to come up here and I'm going to right click on this device. Actually, I need to move this down out of the way, and you will see here I have the option to select capture. So what I'm going to do is I'm going to capture information on Ethernet 1.1, and this should open up a session that I'll be able to RDP to. Now, this is a feature of EvenG. So what I'm going to do is I'm just simply going to click on this, and what I'm going to do is I'm just going to tell it that I do want to map. I'm just going to map it to a folder called pictures. This is going to be for being able to do drive sharing. So I'll just go ahead and hit connect, and if all goes well, I should be able to actually connect to this session. So what I'm going to do is I'm going to say connect always, and it should take me to a Wireshark session. Now let's see what happens, and there it is. Now what we're seeing here is the data, the information associated to the communication or the messages that are being sent across this link. Now in the background we see I'm running CDP, VTP, so it's Cisco Discovery Protocol, VLAN Trunking Protocol. I'm running Dynamic Trunking Protocol, PAGP, other elements. Now that doesn't necessarily mean that all of these are actually running, but it does mean that they're actually being looked for, and we'll actually see these things actually do get sent out because CDP is running by default. Now if we take a look at the configuration here, that's pretty much all we see. Now as an example, I could come in and I could generate traffic. So what I'll do is if I do that ping again, so if I say, let me shrink all of this down just a little bit more. There we go. So let's say I ping 10.1.12.2, but this time what I'm going to do is I'm going to do it with just a single ping. So if I hit enter here, we see the ping, and what we want to do is hopefully we should see some results on this side. Let's see if we can ping one more time. So let's say ping, generating some traffic. I'm not seeing anything, so let's see, can I refresh this thing? So continue without saving. Not seeing any information. Now, something doesn't look right. So let me stop this. No packets captured. And let me start it up again and let's see what happens. So I think something's wrong with the capture. Now, this is I'm going to continue to proceed with this because this is the same kind of thing that you may run into in your own labs. So what I'm going to do is I'm going to come down here and I'm going to just restart that process on Ethernet 1.1. And let's see if it gives me that download again. Yes, it did. So I'll just click on it. I'll go ahead and just for the sake of, we won't do any type of sharing between. Let's see if it lets me log in. So I'll say always connect. And let's see what happens here. Okay, and there we go with that again. Now let me see if I can try that ping one more time. And if it doesn't work at this juncture, then I'll have to figure out what's going on. So there we go. So again, like I said, nothing's perfect. This is an emulated environment, and sometimes you got to kind of like grab something and shake it. But we can see here the ICMP messages, the Internet Control Management Protocol messages that are being sent. And we can actually see here that we have these elements that we're going to be looking at. And these constitute headers. Now, one of the things that I would like to be able to do here, let's go ahead and see if I can close out and go back in, is I want to initiate a session that's going to be a little bit more complex than just a ping. So let's see. Right now, we see VTP and CDP messages are all going back and forth. But what I want to do is I want to initiate an HTTP session. Now, I'm going to do this by initiating that session to port 80. So in this instance, what I'm going to do is I'm going to say I want to telnet to 10.1.12.2. But what I'm going to do is I'm going to tell the system that I want it to connect on port 80, which is an HTTP session. Now, it won't come up as HTTP here. It'll actually come up as TCP because I'm using Telnet to test this. But again, like I said, it should allow me to connect. And now what we see is I see the sessions. Now, remember in the previous class or the previous videos, we talked about the handshakes. We talked about the connectivity, and what we see here is we have this idea of a three-way handshake. You'll notice for this HTTP session that I put in place, I have three different messages. I have a synchronization request, I have an acknowledgement, a sync acknowledgement, and then I have a acknowledgement. Now, what I want to do is I'm going to look at one of these. And to look at it, what we're going to see here is these values right here define my headers. So as an example, what we see here is the fact that this first value, if I go ahead and hit the down arrow here and we take a look at what's going on, this is going to tell me that this is an Ethernet header. When I take a look at the configuration, basically it's telling me what the payload is and a number of elements. But if I want to look at the actual layer 2 header, that's going to be found here, because remember, like we said in class, the layer 2 header is going to be comprised of the source MAC address, which is right here, and the destination MAC address, which is right here. And it even tells me that it's actually sending a payload of IPv4 traffic, denoted by this value here, 0 by 0800. This is referred to as an ether type. Now, the ether type actually defines what the payload is for a particular layer 2 header. Now, if I take a look at the layer 3 header, that's going to be defined here. Remember, where a layer 2 header carries the source and destination MAC address, the layer 3 header is going to actually carry the source and destination IP address. So here is my source IP address, 10.1.12.1, coming from 9K1, and here is 10.1.12.2, the destination address that I'm actually sending this message to. Now, if we keep looking, we see a transmission control protocol area here, and this is actually defining my layer 4 header. This is talking about the fact that I am sending the information to the port of 80 and I'm sourcing it from port 60659. This is called an ephemeral port, by the way. It is a randomly generated high number port that is going to be used to source information to a particular destination. Now, when you see the destination, if it says port 80, or if a device is actually listening on port 80, that means it's the server in the scenario. Now, HTTP is best described as a client-server type configuration. As we can go through here, we see the types and the values associated with it. We should see things that we haven't talked about yet. You'll see elements in here that are going to be defining things like QoS. We see values in here like differentiated services code point. We see the values that are associated to these particular types of communication, and we can even bore down and take a look at it. As an example here, we see explicit congestion notifications not on. You may not know what that is, but I'm just trying to give you guys an illustration of exactly what is going to be contained in these varied and sundry packets and headers that we're going to be dealing with. And this is a perfect example of being able to see the 3 primary headers. This first element defines the fact that this is an Ethernet payload, or an Ethernet packet, or frame, excuse me. The next value determines the contents of the Ethernet header, which is going to be the source and destination MAC address, and the payload type defined by the ether type value. The next value is going to be the layer 3 header, which is going to be IPv4, and then the last value here that we see is the layer 4 header, which is going to be for the transport layer. Now, there are no layer 5 and layer 6 configurations in here. The reason being is that for the most part, most of our communications don't really rely on those headers because we're not doing things like encryption. And a lot of people will immediately think, well, what if I used HTTPS? Well, HTTPS in this fashion is still not going to actually encrypt the information being sent. I can illustrate that point very quickly if I come over here and hit escape and we scroll all the way back down. And in this instance, what I'm going to do is I'll say I want to connect to the secure connection. And here we'll see these values again. And when we take a look at this last payload, what you're going to see is still we don't have any of the values beyond transmission control protocol. So it's not actually encrypting the information. Now it makes sense, or at least it should stand to reason, that if I don't want anything to be able to read the data, it makes more sense for me to encrypt that information higher in the OSI stack. Therefore, if I were to actually use a sniffer like this, I would not be able to see into the actual payload that's being generated and sent via the upper layer protocols. So I just wanted to give you guys a capability or a chance to see this. And this is the cool thing about a virtualization package, whether you're using Viral, GNS3, or whether you're using Eve like I am, because what this does is it gives you a lot more versatility and capability without having to add equipment or have live devices. So again, it's very important for us to pay attention to the way things function. As what you see here just popped up before I leave is the fact that this session terminated. So this is the build up and this is the tear down. Remember, that was the purpose of the TCP and the session configurations. The session area or the session layer builds things out. Well, when the application stopped working, the session layer broke down the section. We can see here fin acknowledgement, ACK, and then fin acknowledgement. So what this translates to, if I come over here, basically it says that the connection has been closed. So again, just a 30,000 foot view of one of the many, many things that we need to be able to demonstrate to Cisco that we understand in order to be able to take and pass the DC ICN exam. I'm Terry Vinson, and I'd like to thank you for learning Data Center with me.